Hello, chemistry students. Today we're going to talk about mole ratios. So some notes, the key notes that you may need is that stoichiometry calculations can go between any substances in a reaction, which means it can go between reactants or the products. It also helps us to find a theoretical yield, which is the maximum amount of product that should be made. It's not the actual yield, kind of like when Kira bakes some cookies. Theoretically, she should be able to make 24 cookies out of her ingredients, but in our house, that rarely ever happens. So theoretically, 24 cookies, actual yield, I don't know, maybe 15 or so. Now let's talk about the mole ratio. You find mole as the coefficients in the equation. So the molar ratio of hydrogen to oxygen would be the coefficients of hydrogen, which is 2. So for every 2 moles of hydrogen, you would need 1 mole of oxygen to react. So the molar ratio is 2 to 1. For hydrogen to water, it would be 2 moles of hydrogen will produce 2 moles of water. So the mole ratio is 2 to 2. Oxygen to water, you'd have 1 mole of oxygen for every 2 moles of water. So the molar ratio for oxygen to water would be 1 to 2. Water to oxygen, you have 2 moles of water produced for every 1 mole of oxygen used. So that molar ratio would be 2 to 1. And lastly, water to hydrogen, you have 2 moles of water produced for every 2 moles of hydrogen used. So that mole ratio would be 2 to 2. Our example is to use this equation right here, this balanced equation, to determine how many moles of water, so I'm going to put a question mark right above the water and put moles because that's what we're looking for, would form if we begin with 32.28 moles of oxygen gas. All right, so this looks like a stoichiometry problem because we're starting with 32.28 moles of oxygen gas and we need to find out how many moles of water. So I'm going to write what I know over here, 32.28 moles of O2. Now you must put the chemical. All right, now if you remember correctly, whatever units we have on the upper left, we always put on the lower right. So moles of O2. Now from moles of one substance, we can go to anything of that substance. So right here, we can put grams of oxygen, we can put liters of oxygen, we can put molecules of oxygen, or we can go to moles of a different substance. Now we're looking for water. So let's go ahead and put moles of water. All right, now we're going to look at our units, and they're going to help us to decide what numbers we put here. So we've got moles of water per moles of oxygen, and this is where the mole ratios come in. So let's look at how many moles of water we have. That's 2. And how many moles of oxygen? There's 1. So there are 2 moles of water for every 1 mole of oxygen. Now I'm going to look and find out, what are we looking for? We're looking for moles of water. And this is what we have on our right-hand side of our equation, moles of water. So I can stop there. I do not have to put another grid here. Now I'm going to cancel my units out. I've got a moles of oxygen on top and a moles of oxygen on bottom, so they cancel, and I'm left with moles of water, which is what I'm looking for. So now it's 32.28 times 2, and that is 64.56 moles of water produced for every 32.28 moles of oxygen we start out with. Thanks for watching.